Understanding the domain of a function is a very important concept in algebra, and it's very common for students to kind of wonder what we mean by a domain. And so I'm going to show you how to find the domains of some common functions. First though, I think it's good that we understand what a domain is. And so the idea is if you visualize a function like this, you have a set of inputs, and into that function you plug in an input that we commonly call our x's. It gets mapped over to an output that we commonly call a y, and so that's what our function does. It bridges these two sets. This first set is what we call our domain. In other words, it's the things that we can plug into our function and still get a real answer. And so in algebra, there are four basic kinds of functions you deal with when you're looking for domains, and I'm going to show you how to find the domains of each of those. The first one is polynomials, and a polynomial would be something like this. And for polynomials, the domain is pretty easy to find because I can pick anything I want over here, anything I want, and plug it in and still get a real answer. So for that reason, you don't have to factor, you don't have to find zeros, nothing like that. The domain is always negative infinity to positive infinity. The second kind is rational functions, and rational functions would look something like this. Okay, so rational functions can be defined as polynomials divided by polynomials. And the thing is, here, since polynomials you can plug anything you want, I could basically plug in anything I want into this rational function as well. So my domain could be anything over here I wanted, with one exception. I need to make sure that my denominator is not 0. Okay, so for this example, I need to make sure that x minus 1 and x plus 2 are not 0. Okay, so that means for the first equation I have that x can't be 1, and for the second equation I have x can't be negative 2. So that's like I take the number line and I cut out negative 2 and 1. But anything else works. So as a set, the way I write this domain is I write it as negative infinity up to negative 2, anything between negative 2 and 1, and then anything from 1 to infinity. Okay, and you can visualize that on this number line. It's basically that I took the number line and clipped out negative 2 and 1. And so in general for rational functions, you take your denominator, anything but the denominator being 0 works fine. Okay, the third type of function we have to deal with is even radicals. And so an example of that would be something like a square root. Okay, so now if I'm visualizing again my two sets and I'm plugging in things from my domain into the function and getting an output in the range, then here with a square root, for example, if I plug in x equals negative 6 and I get the square root of negative 1, well, that's not a valid output in the real numbers. So here in this example, negative 6 would be outside the domain. Okay, so how do I find what needs to be in the domain for an even radical? Is that I need to make sure that what's under the radical is greater than equal to 0. So in this case, that means that x has to be greater than or equal to negative 5. Okay, so on the number line, take negative 5. Negative 5 is included, and anything bigger than that will work. But anything less than negative 5, for example, like negative 6, will be outside my domain. So for example, if I plug in 0, I'm going to get a valid output. If I plug in negative 10, then I don't get anything over here. Okay, so as a domain, my domain then as a set would be written as negative 5 with negative 5 included up to infinity. Alright, so that means we've now covered the two worst cases, the even radicals, which we have to set what's underneath the radical greater than or equal to 0. And the second case would be these rational functions where we have to make sure the denominator can't be 0. Alright, the fourth function we have to deal with is odd radicals. And odd radicals look something like cube roots. So you have like the cube root of x plus 5, for example. Now in this case, it's tempting to try the same strategy as even radicals. And the problem with even radicals is that you can't have a negative underneath your radical. But with odd radicals, that's not the case. For example, what's the cube root of negative 8? In other words, what thing multiplied by itself 3 times is negative 8? Well, negative 2 cubed is negative 8. Okay, so here you can plug in negatives from the domain and still get a real answer. So for odd radicals, there's nothing to really worry about. Your domain's always going to be negative infinity to positive infinity. Alright, now we have covered the 4 basic cases that you see in an algebra course when you're worried about domains. And again, those are polynomials, in which that's everything, rational functions, where the denominator can't be 0, even radicals, where you have to make sure what's under the radical is greater than or equal to 0, and odd radicals, which is everything, negative infinity to infinity. I hope this makes sense. I hope the concept of domain makes sense. Make sure you wrestle with this until it does. If you have any questions, please let me know. I'd be glad to help. And thanks for watching.